week two of Intro to Coding. Both today and tomorrow, we'll be finishing up our sections on JavaScript and covering kind of what we think are the bare basic JavaScript concepts that you need to know. And then on Wednesday, we'll be working on a project that hopefully puts together a lot of what we talked about already kind of into one piece of work. Oh, sorry for the background noise there. Okay, so today's portion on JavaScript is it's a little bit it kind of helps us dive a little bit deeper into the maybe a more intelligent part of JavaScript, right? So far, all we've really done is create variables and use them. And then today we're going to talk about, okay, how do we use it, when do we use it, and kind of talking about something that called the control flow or the logic that powers a lot of functions and processes that we see. But before we do that, we just want to do a quick reminder on debugging. And really, like with debugging, just note that debugging by no means is a bad thing. And what I mean by that is a lot of people when they write software, especially when they're first starting off, they run it, they write the code, it doesn't work right away, and they think that that reflects upon them as a programmer, as in I'm not good, I'm not naturally cut out for it, etc. When in reality, with almost all software developers, whenever you write a big piece of code, when the first time you run it, you kind of expect it not to work, right? You expect something to go wrong, and as a developer, your job is really kind of now go through the code line by line and figure out what actually went wrong. And so whether or not you get it right on the first try is by no means an indication of your coding abilities, but rather being able to debug thoroughly and quickly is actually more of a sign of an accomplished software developer. So yeah, so developers spend way more time debugging code than writing it, and debugging is more of an art than a science. After you do it long enough, you start getting a feel for where the code is probably wrong, where the code doesn't quite make sense, where all of these factors kind of play out. The two main types of errors that we'll talk about today are going to be syntax errors and reference errors. But before we do that, hopefully, well, not hopefully, but I'm sure all of you have seen this. In the screen on the right, if you notice, this is a screen that somewhat probably looks very familiar to you guys based on some of the workshops that we did last week. And what we mean by that is a lot of times when I was jumping from room to room, I saw you guys were trying to run code, and when you did, there were errors that came popping up, right? And actually, most code editors nowadays, when you run code and there's an error, most code editors have actually gotten really good at giving you back messages that at least start helping you investigate, that at least help you start to investigate what went wrong or kind of where your code is not working properly. And so while you may not see this exact screen, you'll definitely see output that looks like this in almost all JavaScript coding environments that you use. And if you look on if you look at the image on the right hand side, if we jump over to line 3, right, you'll see right away that it tells us the error is reference error. Sum is not defined. And beneath line 3 is a bunch of lines 4 through 7 that seems that seems pretty confounding at first. But if you actually look closely at it, what you'll notice is that those are actually files. And not only are they files, but they're actually line numbers too. And so what that means is this is something that we call a stack trace, and it's super powerful and useful for figuring out code errors. Because what a stack trace does is it not only tells you the error that the code encountered, but it actually tells you all the lines of code that the computer ran to get to that error. And so here on this example, line 4, once again, it recaps the error and says, hey, when I ran your code, I got a reference error. And the error is this variable called sum is not defined. If we go to line 5, that will tell you the line of code that most recently ran for us to trigger that error. And if we look on the far right-hand side of that line, you'll notice eventually we get to after the 7357 backslash, you'll notice we reach a file called onlyoz.js, followed by a colon with a line number, followed by a colon with another number. That's actually a very useful thing for us to see, because what that tells us is that onlyoz.js is the last file that was run before we got to the error. And then the first number after the colon tells us the line number, and the second number after the colon tells us the character number. Now, in most cases, the line number is more than sufficient. But essentially, what line 4 is telling us is say, to get to the error on line 4, I ran the onlyoz.js file. I ran it up to line 11, and then when I got to character 7, I got the error that you see on line 4. Okay, so that's why we call it a stack trace, is because you're actually able to trace the code as it runs through, and more importantly, figure out at what point the code kind of breaks down or at what point the error got triggered. Now, the stack trace is not a panacea. It's not like it will solve everything for you off the bat. A lot of times you may see an error manifest in one place that actually will happen somewhere else, right? If I go back to a real world analogy, right? If someone's driving a car, right, and the airbag didn't open up correctly on the collision, it doesn't mean the accident. It doesn't mean that the airbag was broken because of the collision. It means the airbag was broken maybe during the manufacturing process, right? So maybe the actual error happened somewhere else. But at least this stack trace helps us now, at least from the computer's perspective, start understanding at what point did the error get triggered. And now when we start looking at this code, if this code was thousands of lines, rather than kind of floating around blindly and saying, oh, let's just read the entire code and figure out what went wrong, now we can actually say, oh, okay, line 11 is kind of the first time we see this error. Let me try to check where line 11 comes from, and then try to work backwards to figure out, kind of where the logic started breaking down. So, like I said, most code editing tools will now have this feature for you, where if you write code that's not correct, it will tell the error not only tells you what's wrong, but it'll also give you a pathway to understanding how it got there. Line 6 then is what runs to get to line 5, and then line 7 is what runs to get to line 6. Usually you don't need to go that deep. Usually with most people, when they see an error, if you look at the last line of code that the stack trace shows, it should get you a rough approximation. Maybe you'll go one level deeper than that, but it's just like a really nice handy way for you to take a look at error and have a better idea of what went wrong, other than just, hey, your code's not running correctly. Yeah, so the line number is a good place to start, but it may not be entirely accurate. But once again, it's a place for you to kind of start thinking about, oh, like what could possibly have gone wrong at the code point here? Am I using a variable? If so, at which line did the serial get created on? And kind of, it allows you to have more of a sense of where to start your investigation. And then hopefully I don't need to help folks to Google unfamiliar errors. Although as you go through this, the most common types of error that you'll see are basically going to be syntax errors and reference errors. Syntax errors are basically things that as the name indicates, just like, hey, when you wrote your code, you had grammatical mistakes, right? These could be things like you're missing, like you wrote an open brace but you forgot to close a brace, or you had a parentheses you forgot to close, or you had an extra comma somewhere else, or you had a semicolon, or you had an arrow. Basically, whenever you write code and you have to use the improper punctuation, that's when these errors really crop up. Putting a semicolon at the end of a line of code in JavaScript, it's best practice, but it's not necessary, right? What we're talking about here are actual typos are necessary. So later on in the course, one of the things we'll talk about is a for loop. Well, in a for loop, you actually need to be very clear about where you place your semicolons within the conditional statement, because if that's wrong, then your for loop can't run, right? And so just so we're all aware, these are things that are not just optional things. These are things that are fundamental to your code. And usually when you have a syntax error, the computer will give you some sense that it is a syntax error. For example, if you write an open parentheses without including a closed parentheses, it will say, hey, I expected to see a closed parentheses here. I didn't see it, right? Usually that's kind of a nudge for you to think, oh, okay, maybe I forgot to close off, one of my parentheses or brackets. It's also the reason why indentation is really important, for you to make sure that you actually do get your parentheses or braces or brackets matched up correctly. The other type of error that you'll see a lot of is something called a reference errors. And a reference error basically is just, usually it comes around when you try to use a variable that doesn't exist. There are a few causes for the root causes for reference errors, but for now, and this is going to sound silly, but one of the most common causes for reference errors is just because people misspelled the name of a variable, right? If I have a variable called car and I accidentally spelled a CAD somewhere, well, JavaScript's not smart enough to know that you actually meant car. It will think you're actually looking for a variable called CAD, and it'll tell you, hey, the variable CAD does not exist. And as a human, that's kind of your role to step in and say, oh, my bad, that was a typo, I meant to spell it CAR, and then use it that way. So very rudimentary, and these are types of errors that will kind of decrease as you program more and more and get more comfortable. But more importantly than just knowing these kinds of errors, we also want you to get comfortable with the idea of running your code, seeing an error, not getting scared by it, but rather understanding how to triage it, how to figure out what the next step is towards investigating it. So, okay, yeah. So that was kind of our quick primer on errors. And now we'll actually move on to kind of the more logic or the more control flow part of JavaScript. Oh, yeah, sorry, go ahead. Yeah, for the most part, you shouldn't have to worry about it. Like sometimes those are running by for the computer on like kind of background processes. Usually, like the most recent lines will definitely make sense, and it'll make less and less sense as you go down it. So you just start with the most recent. So the way that the stack trace works is line 5 is the most recent line that was run. Line 6 is the second most recent line that's run. So as you go more down that line, the kind of the older the code gets. And so usually people start with the most recent errors and then kind of work your way down. Yeah, yeah. HTML is a little bit different because some like linters might catch errors. For example, if you start with like a p tag but then you forget to close it, it might catch it. But HTML is more like visual. Like it's in most environments, it will try to just render the images to the best of its abilities and assume where the closing are. With JavaScript, it's like it's actually a logic, so it's like it's kind of like you can't move forward unless you know what you're doing on this line, and so the code will actually just break. Yeah. Yeah, yeah. I mean, or you can think of the opposite way, right? Like with HTML, like a human can see what's wrong, but a computer can't see what's wrong. But in a highly logical process, a computer can say, "Hey, your logic stopped making sense because of something," right? And to a human, it's actually hard to intuitively pick that up. Yep. Any other questions? Cool. All right. So then the next one we'll talk about are basic conditional statements. Conditional statements really gets to the heart of what programming is, right? Basically, it controls the logic flow in our statements, and the most simple kind of conditional statement is what we call the if-else statement. In English, right? If you think about an if-else statement, it's basically if this, else that, right? It's kind of like a very binary decision. It's kind of like the proverbial fork in the road. Um, it's something that allows us to say, hey, if one thing is true, then we'll do this. If another thing is true, we'll do that, right? And just notice like the syntax here, right? As you can imagine, if and else, the words themselves, they're reserved keywords in JavaScript. So you can't have a variable called if, you can't have a variable called else, right? And in the if statement, notice how after the if, we have a parentheses. And in between the parentheses, we have something that we call a conditional statement. Conditional statements are basically statements that give you one of two possible outcomes. Either it's going to be true or truth-like, or it'll be false or false-like. And we'll talk about that in just two more slides. But essentially, if we look at the if-else statement here, on line 4, we have our if, and we have our parentheses, and we put true inside of it, which just basically means like, hey, we're going to automatically make this true. And then at the end of it, we have a curly brace, right? We have a block of code in there. And then that block of code basically says, if the thing is true, execute everything in the curly braces that start on line 4 and on line 6. Essentially, run line 5. On line 7, then, we start with our else statement, which basically says, hey, if the true criteria was not met, else run the block of code that's in between the curly braces on line 7 through 9, essentially running line 8. Okay, so this is kind of how we start kind of making these functions more intelligent or a little bit more nuanced and just saying, let's run all the code from line 1 down to line 1000, right? Here we actually have a condition where if line 4 is true, we run line 5. If it's not true, we run line 8. So imagine that this also kind of gives us a very clear limitation, right? Which is that no matter how many times I run this code, I can never run line 5 or line 8 or I can never run line 5 and line 8 simultaneously. I have to always pick either one or the other. And so to kind of give you a more graphical representation of it, if you look at the top half of the page, right? On the left-hand side, my code says if, and then in between my parentheses, I have my conditional, or the thing that I'm checking. And in it, all I'm checking is if the number 9 is greater than number 8, right? Which is true, because that's going to say that that's a true statement, right? That logically is true. If it's true, then I run the console log, this is true. Otherwise, I run the code in the else statement, which is console log, this is false. And so if you look on the right-hand side, that's our fork in the road. That's our decision tree, right? Is 9 greater than 8? If true, we run whatever's on the left-hand side of the arrow. If not true, we run whatever's on the right-hand side of the arrow. Does that make sense, everyone? Okay, so that's pretty simple, right? We have an if-else statement. It's just one of two possible values. Well, obviously, sometimes things get a lot more thornier than just if or else, right? Sometimes there's many conditions that we need to check in on. And so on the second half of the page, we also have something called the if or else if loop, right? And what the else if loop is basically a way for us to kind of add more conditions to something, okay? Yeah. And I'm trying to think how to explain this most logically. Okay, so on the first third of this is saying if num is greater than 8, just console log for me num is 8, right? And that's what we see on the right hand side on the diagram, right? If num is greater than 8, if that statement is true, we console log out num is greater than 8, and we're done. And we skip the else if and the else, right? Because remember, in an if else if or else condition, only one of those things could ever be true at one point, right? We can't have two of those or all three of those being true at the same time. Only one can be true. So it's kind of like if we hit the first true, we say, great, we don't need to check the other two because, they may be true, but it doesn't matter because we already kind of met our criteria. Now, if num is not greater than 8, then we move on to our else if statement. And what the else if statement says is, okay, now we're saying if num is greater than 6, we're gonna console log the block of code in the else if statement, right? In this case, we'll console log out num is greater than 6 and less than 8. But if that's not true, then we go to our else statement, which is console log num is less than 6. The graphs, I'm sorry if the charts didn't come out as we wanted to, because we wanted to kind of make it all more skewed on one side. But essentially, one of the things you would recognize here is that this is not any different than the if-else loop on the top half of the page, right? What we essentially done is we've just combined two of them together. The top half of it was saying, hey, if this is true, do this, else do this. Well, on the bottom half of the page, what we're saying is, hey, if this is true, do this. If it's not true, well, hey, we now have another separate if-else statement, another decision tree, right? Except we don't call it a if-else statement, we call it a else-if-else statement because we want to make sure people, when they look at this code, they understand that these three statements are all checking for theoretically one set of criteria, right? In all three cases, we're checking to see what the value of num is. If it's greater than 8, then we'll do this. If it's not greater than 8, but it's greater than 6, then we'll do these things. And then finally, if it's not greater than 6, then we'll just do this third thing. And so the useful thing with else if statement is that you can actually add as many options as you want. So we could have a if statement followed by 10 else ifs followed by an else, right? Because if you think about it, like on the tree diagram here, like there's nothing stopping us from adding an extra tree anywhere else on this, like any of those branches, right? Like if num is greater than 8, well, I could just say if true, print this out. Or if true, I can say, well, like what if I want to add another if else statement inside of there too, right? What if it's greater than 9, or what if it's greater than 10, and so on and so forth. And so if else is a very basic building block in JavaScript, but recognize that it is a building block. It is meant to be used in conjunction either with more of itself or with other functionalities too, right? And so these things, as you go through them, really make sure that you understand kind of the logic behind it, as opposed to just saying, oh, let me just copy and paste this code here. Because as with anything in programming, like unless you truly understand it, when you try to use it with a slight modification, it's going to get really tricky really fast. Any questions on the if, else if, and else statements? And by the way, notice how this is one of the kind of benefits of JavaScript, is that it's written in a way that kind of reflects how we talk, right? If I said, hey, if they have Coke, give me a Coke. Otherwise, give me a Pepsi. It's kind of like the way that the language is written is somewhat mirrors the way that we normally communicate anyway. So that's kind of one helpful side effects of JavaScript. Yep. Well, so if we think about so I mean, we can either do it at multiple levels or we can do it all at the same level, right? Let's say I want to determine what kind of marketing email to send someone, right? I can say for this customer, if they're a man, then if they're between the ages of 60 and 70, do this. If they're aged between the 40 to 60, do this, right? And then on beneath, I can say, if they live in the West Coast, do this. If they live in the East Coast, do that. And you can easily compound more and more logic. Now, it's bad practice to have too many layers of logic in that way. Usually, if that's the case, then you probably want to rewrite your code in a different way. But the point still stands like actually in most programming, this is kind of what we're trying to do is just take a piece of data and either try to understand it or filter it or manipulate it in some way to reach a final decision. Yep, cool. Cool. So then the last thing we'll talk about today is, well, I said, if this statement is true, we'll do this. But what does true actually mean? And so this gets to the idea of kind of why a lot of people say programming is very similar to math, right? Is because to determine whether something is true, well, or not true, we have something called comparison operators. And except for this first one, the rest of them hopefully are all things that are very similar to math that we've already kind of seen. This doesn't go past kind of high school math. So the first one, and arguably the most important one, is just the three equal signs in a row. This is the one that we use to check in JavaScript if two things are equal. Other languages use two equal signs. JavaScript uses three. There is a two equal sign operator, but we strongly caution you against using it. I won't go into too much detail here, other than the fact that the way that compares equality is not the way that we typically think about equality from like human terms in computer in the way that JavaScript is written. It has a different meaning. So whenever you try to compare whether or not two things are equal, always use the triple equal sign. This just checks if two things are equal. And then the other one that's a little bit unique then is also the exclamation mark equal equal. The exclamation mark we'll cover in the next slide actually, but the exclamation mark is called a bang, B-A-N-G in JavaScript, and it basically means not, right? It means the opposite of. And so equal means if two values are equal. Exclamation mark equal means check if two values are not equal. And then we have our greater than operator, or sorry, less than operator, less than or equal to operator, greater than operator, and then greater than or equal to operator, right? These last four should be somewhat familiar to most folks, I think. But yeah, now we've kind of started developing tools or syntax that allow us to, like, remember in programming, it's really bad with ambiguity. We just want very precise yes or no. And so now the answer to any of these questions, right, is something equal, is something greater than, is something less than, right? These are all going to yield us yes or no answers, right? And so that's going to become really helpful for us. And so now we're going to move on to so now we know how to compare things. The question becomes, how do we capture the results of those comparisons? And here we get into Booleans, which we talked about on Wednesday, right? If you remember, Booleans are a data type in JavaScript that only has two types. Things are either true or false. JavaScript actually goes one step further, right? Rather than saying something is just true or false, we can also sometimes say if things are truthy or falsy, which basically means that they reflect a true or a false context. And so this is the part that I don't want you to get too kind of confused on, because this is part of a much bigger deep dive on Booleans that we'll need to do. But just know that in JavaScript, most values are truthy, as in they represent a true value. If someone if kind of like if someone forced JavaScript to say, hey, is this string true or false? Almost all strings are true, right? And we'll talk about the false ones on the next slide. But things like any number that's not zero is going to be a true number. Any string that's not blank is going to be a true string. any array, any objects are all going to be true, right? Or truth-like. And so then the flip side of that is, where are the falsy values? Well, the false or false-like things in JavaScript are for strings or empty strings. For numbers, it's 0. And then nulls, undefines, and NaN, which stands for not a number. These are all going to be falsy values. These are things that you don't need to memorize for now, but when you do the workshops, you'll come across them again. They'll cover in a little bit more depth. But just know that in JavaScript, whenever we try to say, whenever we try to measure a condition, or whenever we try to say, is this true or false, any value in JavaScript can essentially be boiled down to either true or false, right? Like every single value, obviously true and false are the most straightforward ones, but any other value can essentially be coerced or converted into a true or a false value. And these 5 values that you see on this page, empty string, 0, nulls, undefines, and non-numbers, these are the only falsy values in JavaScript in addition to the actual false value itself. So then, one of the really handy ways for us to really quickly kind of change something from true to false or false to true, then, right, is this bang operator, is this exclamation mark. Essentially what a bang operator does is you put it before any value and it'll give you the opposite boolean of that value. And so if I put it in front of true, I get back false. And on line 6, if I put it in front of a string, well, is that string true or false? Only empty strings are false, right? So all other strings are true, so the string ABC is true. And so when I put the exclamation mark in front of that true, I get back false. Any number is true except for 0, and so 100 is true. So when I put the exclamation mark in front of the 100, I get back false. And then any array and object are true, and so when I put the exclamation mark in front of any array or object, I get back false. And then this lends itself to something called the double bang operator, which is the opposite of the opposite, right? So this is sometimes hard to think about if you think about it at the opposite of the opposite. The easiest way that I found to think about it is you're basically just taking any value and just asking, is this a truthy value or is this a falsy value, right? So on line 4, is true a truthy value or a falsy value? Well, it's a truthy value, so therefore the value is true. On line 6, is the string ABC a truthy value or a falsy value? Well, it's not an empty string, so it's true. Is 100 a truthy value or a falsy value? Well, it's not 0, so it's true, right? And so a double bang basically says, take this value and give me the Boolean version of it. A single exclamation mark in front of it says, take this Boolean value and give me the opposite Boolean value of it. And remember, in all these scenarios, all we're trying to do is get to a true or false value, because once again, that's kind of how we decide whether or not to execute on some of our logic, right? Most of our logic is going to be dependent on if this criteria is met, do this. If it hasn't met, do something else. And so here we're just going to say, if this is met, do this. Any questions? Well, sometimes you'll want to convert something from a number to a true or a false value. And so this is just like a quick way for us to do that conversion. Yep. The last two things we're going to talk about are and or operators. And operators are basically things that allow us to compare multiple things in sequence, almost in a chain, right? If I say go to the store and get me, milk and bread and juice, well, unless you get me all 3, then you've kind of failed in your mission, right? And that's what the AND operator really is trying to do right here too. So on line 4, when I say compare 10 and apples, right, it's basically saying is both the first thing and the second thing have to be true. And if those 2 things are both true, and then it says and 0, then this third thing has to be true as well. And so at any point, if something breaks in this chain, aka if I have a list of ands and one of those things is not true, then this is going to give me a false. Right? So on line 4, if I do 10, is 10 true? 10 is true. So I go and apples. Is apples true? Is true. And 0. Is 0 true? No, 0 is not true. And so at that point, I can return back, hey, this chain fails at 0. On the other hand, if I look at line 7, right, if I'm checking the chain, it's saying lucky, so the string lucky, and is the string lucky true? Yes, it is. And is the string number true? Yes. And is 7 true? Yes. Great, all 3 are true. So then we can write back the last truthy value, which is 7. And so the and is basically a way for us, it's a shorthand for us to check multiple things in sequence kind of at once. And so then the opposite of that would be the or operator, which is written by as two lines, or they're called pipe symbols. And so for the or operator, basically what it's saying is let's check in sequence as well, except if you think about the way we humans use or, right? It's saying if any of these conditions are met, then we're good. And so here we're saying if the first thing is truthy, then we're good. If it's not, let's check the next thing, right? So on line 4, we check with null. Is null truthy? No, it's not. So then we check on the next one. Is undefined truthy? No, it's not. Then we check on the next one. Is the string happy truthy? Yeah, it is. Great. We can stop right there and say we found at least one truthy value. Similarly, on line 7, is false truthy? No, it's not. Okay, then we check null. Is null truthy? No, it's not. Then we check 10 is less than 0. Is that true? No, 10 is greater than 0. And then lastly, we check not a number. That's truthy? No, it's not. And so therefore, we can return back the last false value. So the and or operators are basically ways for us to check multiple things, multiple criteria at once in a certain sequence. Any questions there? Cool. That's all I have for today, right? So it's about errors, it's about using kind of basic logic, and it's about using coercion and truthiness to now start figuring out, okay, how do I write code that does, not just run it straight through, but now it kind